for 11.2, arcs and chords. We have our poster with all of our labeled, or not labeled rather, parts of a circle. An arc can be either major or a minor arc. A minor arc is an arc whose parts are on or in the interior of a central angle. So in other words, this would be a central angle. So a minor arc would be this arc between the angle. So this red part. Not the whole red shaded, but just the arc on the edge of the circle. So that's a minor arc. A major arc would be everything else. Okay, minor is kind of small, major is rather big. Alright, a semicircle. Well, like, duh, it's half a circle. Okay, you've learned a semicircle a long time ago. The measure of a semicircle, which would be from this orange line all the way around to the other side of the orange line, 180 degrees. It's all the way, this is 60. Central angle is this angle right here. So we have a point from the center of the circle, we make an angle. A central angle is that angle right there, made by 2 radii. Good. Adjacent arcs and congruent arcs is our next 2 vocabulary words. Congruent arcs, well, we know what the word congruent means. It means equal. We know what arcs are. So congruent arcs would be 2 arcs that are equal. And adjacent arcs would be arcs that are next to each other. Hence the word adjacent. Alrighty. Let's do some examples. One of the biggest things that you use central angles for is going to be pie charts. Okay, and pie graphs. You see them all the time in every one of those graphs that you use. So if you have a circle graph and you are asked to find the measure of a central angle of the arc, you can use its percentage to tell you. Okay? So for example, if I have this beautiful pie chart, it's got some pieces on it. Okay, and it tells me that this pie wedge here is, say, I don't know, 20%. Nice round number. It's not quite 25%. 25% would be a fourth, right? So you know what? 20% is probably a little too much. Let's call it 15. I can use that 15% to find the angle. The total measure, or the total degree measure of a circle is 360. So if I want to know this angle here, I need to find what is 15% of 360. Punch it in your calculator. 360 times 0.15. You turn it into a decimal so you can put it in a calculator. Once you find that out, you find it's 36 plus 18. You get 54. Hello. After lunch, doing some bad math there. So you find out that the degree is 54 degrees. Now let me know if I make a mistake, okay? Moving on to the next example. Using arc in the Arc Addition Postulate. You have an Arc Addition Postulate on page 757. 757, it says the measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. Okay, that was a whole lot of big words for nothing, right? Of course, all our postulates are like that. No words. If I have this arc, and I have this arc, I know the measure of this one, I know the measure of this one, I can add them together, and that'll be the measure of the whole thing. Again, duh. Yeah. Some things are just simple. Alright, your next theorem talks about, actually has 3 different parts to it. We have in a circle or in 2 congruent circles. Congruent central angles also have congruent chords. Okay? So, let's give us a new circle. That's our beautiful circle. And we've got A, B, C, D, and E. we know that this angle and this angle are congruent. So because we know those are congruent, then we can also conclude that line DE and BC are going to be congruent. In other words, this line right here. Because remember, a chord is any line that has two endpoints on the circle. Okay? Chord is any line that has two endpoints on the circle. So this is congruent to this, then this is congruent to that. That's the first part of the theorem. You can also do the reverse. If you know that these two are congruent, then we know the angles are congruent. Okay? And the last part, congruent arcs have congruent central angles. Let me get a different color for this. These arcs here, you stop the tape. Is it still zoomed in and everything? Awesome. Alrighty. So the last part of this told us that if this arc is congruent to this arc, then we know that this angle is congruent to this angle. We would also know the reverse is true. Okay? Alrighty then. Let's apply that. So let's say I've got, knowing all that, let's apply those. Got another beautiful circle. If I have this chord, and this is R, S, and I know that RS equals 3x, and then I've got TU, which is 2x plus 27. Okay? And the given information is that RS is congruent to TU, so I need to find the measure of arc RS. Okay? Oh. Oh, I left out one thing. This arc is congruent to that arc. Oh, and I apologize. This goes with that. There we go. I drew my arrows too big. 3x is the measure of this arc. 2x plus 27 is the measure of this arc. Okay? And we're told they're congruent. Same thing we've been doing on a lot of other things. We set the two things equal to each other, the monomial and the binomial. Set them equal to each other, find the value of x. So we've got 2x plus 27 equals 3x. Subtract 2x from both sides. We get 27 equals x. We go back and plug it in. 27 times 3. And we get 81? Yeah. Okay? That's how you apply those. Alright. Now, using radii and chords is the last example. If I were to have a chord and a radii in a circle, so draw that out on your paper and see what kind of shape you get. You might notice what we can do with it. You have a circle, you have a radii, and then you have a chord that goes right there like that. You're told that that's a right angle. Do you see a shape I can make? That's it. Yeah, I can make a triangle. Okay? So if I know that this right here equals 2, and I know this is 3, then we can also use some Pythagorean Theorem to find out everything else. Okay? But let's think about this. If this is a right triangle, and I know this is 3, what has this got to be?
5. Yeah.
Pythagorean triple, right? Okay, then you can use that information to find anything else that you might need to find. Okay? Left is it. Stop tape.